This is a write-up for the NonHeavyFTP challenge of the Real World CTF 2023. In this challenge, which is a clone and pwn challenge of difficulty baby, we have a FTP server and some attachment is given. In the attachment, we have a Docker file and a configuration file. In this Docker file, it takes the code from GitHub, takes the LightFTP service version 2.2, and it just extracts it on the Docker container. Then we have a configuration file, and all this configuration file shows that we have an anonymous user with read access to this folder. And this folder can be seen in the Docker container to only include hello.txt. So that's the only file that will be readable. It should be readable if everything is secure. So let's try to check out what LightFTP is all about. So first, real quick, if we look at some CVEs, we can see that LightFTP version 1.1 was vulnerable to a buffer overflow vulnerability in the write log entry function. So you know, that might be interesting. Maybe they still have some kind of buffer overflow vulnerability. And yeah, let's just get to it. Let's just check out the source code. But before we do that, let's just do Docker build and then a Docker run, and then we can have this FTP server running locally. Let me see if this works. So let's try to connect to it anonymously, enter some random password, and then we can see that we are indeed logged in. If I, for example, type ls, you can see that there's just one file called hello.txt. Does this work? Invalid command. Retrieve hello.txt. Get hello.txt. Right. So you see, you can retrieve a file. If you look at the file, it says hello from LightFTP. Okay, that's cute. I mean, everything works. So let's get to analyzing what this thing is all about. So we're gonna look at the source code. Here we have the LightFTP source code. I'm gonna start with main.c. And here we see that it parses some config file, and then it will run the FTP main function. And we're going to go through this yada yada yada. It's going to accept sockets, and then for every socket it starts this FTP client thread, and then every connection gets its own context, which will be important later on. So we have this FTP context per connection, and then it's just gonna listen for commands that are received from that connection, and it's gonna start the appropriate function for those commands. And here we see a mapping of those commands to the corresponding functions. So for example, go to the FTP user function. We can see that it will accept params, which will be the username. It's going to write something to the logs, and it will then write a string to this file name buffer. In this case, it will say, oh, okay, you logged in with that user, that's cool. You know, you need to enter a password next. So it will use this file name buffer to store this string. It will send it to the user, and then it will actually use this buffer again to store the username that you sent. That's going to be used later on with the pass command. Now, what's interesting about this is that you have this buffer called file name, but it's not used as a file name. It's used for all sorts of things. And it's also used in between functions. So let's now first look at how FTP works. Here we have Wireshark listening for port 2121, or filtering on port 2121, I should say. And here we have our terminal window. Here below we are running the Docker container locally, and I'm just gonna connect to it. You can enter a random password for the anonymous user, and we're gonna just say ls. So it's gonna show the file name. Now what happened in the connection? Oh, you can see that underwater the FTP command is sending syst features, so it knows the features. But this is actually the interesting part. So when you say ls, it will actually say list. But what you can see is that the contents, so this, what we received from the server, wasn't received via this connection. However, we also see that there's this thing, passive mode, that is being entered apparently. And what happens here is that the server returns a port, and this port is a asynchronous connection over which the list is sent. If we create a test script, and we're gonna connect to our Docker container, we can log in. We can enter this passive mode, and then filter the port. We're gonna connect to that port over a separate connection. So now we have two connections open. One is the normal FTP connection, and one is the passive connection. Then if we say list, we should be able to receive the contents of the root folder over our passive connection. So let's try and do that. Test. And there we go. So that's how this FTP works. So we have this asynchronous connection thing going on, and this is actually what where the vulnerability lies. I've spent a lot of time looking at all the functions, seeing if there are buffer overflows, and maybe they missed something, but this wasn't the case. It's a race condition. So getting back to the code, let's see. We are going to look at the list command. FTP list. So you can give it a directory. Params will be a directory. It will create the path. So that is like the path in the FTP space that you're allowed to be in, and it will actually just send you the contents of the directory. And how this works is over here, these three functions of these three things, actually these two, this is actually what's used to check if you are allowed to list the thing that you're trying to list. So I've looked at FTP effective path. I couldn't find a way to do directory traversal to get out of the allowed space. And then here it will check, or this actually will check if the thing that you are listing is a directory. So you could think, well, there's no way out of this. But again, it's a race condition. The thing is that it creates a thread, list thread. And in this thread, it's gonna create this data socket. And in this data socket here, if you see mode is passive, it's going to try and accept a connection from the client. And this actually has a little timeout, let's say. So you have some time between the validation of the file name and actually sending the contents of it to the user. Let's see, FTP list. Am I saying this correctly? Yeah. So in list thread, it's gonna do the socket thing, And once the socket is open, it will actually start writing the content over here. It will start writing the content of the file name folder. But what we saw earlier was that this file name buffer is overwritable in other functions. And I use the FTP user command. So again, over here, we can actually just copy, if we enter a user, then it will be copied to this file name buffer. And we can exploit this. So here we're just going to say user. Let's say it's some path traversal. Let me check if I'm doing this correctly. Yeah, so actually we want to put this below. So we first say list, and then over, this is going to listen for passive connection, and this part is going to overwrite file name buffer, and here we're gonna actually receive content of file name buffer directory. Right, so let's check this out. And as you can see that we are now receiving the contents of the root folder. Wait, is this the root folder? There should be like a flag file in here. Oh, there we go. I was in the wrong folder. So, should be a flag file. Here we go, here's the flag file. And then we can actually use the same thing with the retrieve command. So if we say retrieve, this has to be a valid file name. So say retrieve hello.txt. The retrieve function is going to check if we are allowed to access hello.txt. Then we're just gonna overwrite the file name buffer, which again is also used by the retrieve command to overwrite the file. As you can see, this was the flag I've put in the local container CTF foobar. So our exploit works. Let's do that again. This time on the CTF server. Oh, there we go. Sometimes you do need to do it a couple of times. Then here is the flag file. And that is it. There is the flag. So a big thank you for the Real World CTF creators. It was a really fun challenge. Thanks everybody for watching. Don't forget to like yourself, and I hope to see you next time.